During the 1780s, as the Montgolfiers were launching hot air balloons with the help of their fantasy Montgolfier gas, a genuine lighter-than-air gas was also being tested for balloon flight. On the 1st of December 1783, 10 days after the first manned hot air balloon flight, fellow inventor Jacques Charles launched the first manned hydrogen balloon flight. Hydrogen is less dense compared to the elements that make up the atmosphere. But what if it were also heated? Would it become even lighter? 4 years after the pioneering balloon flights of 1783, Charles filled 5 smaller balloons, each to the same volume, but with a different gas. He then heated every balloon to 80 degrees Celsius and saw that they all expanded by the same amount. Although he failed to publish these findings at the time, they were later credited to him by natural philosopher Joseph-Louis Gay-Lussac. Charles' law now famously describes how the volume of a sample of dry gas is directly proportional to temperature, all else being equal, such as air pressure and gas amount. As well as hot air balloon flight, Charles' law can explain rising thermals of air in the atmosphere. When the sun heats the Earth's surface, it acts as a radiator and warms the air immediately above. That air expands as it warms, and its lower density compels it upwards. We see this all the time. On a small scale, rising air gives us fair weather clouds, showers, and thunderstorms. On a larger scale, rising air results in tropical cyclones, low pressure, weather fronts, and global wind circulation. The engine that drives hot air balloons is ultimately the same engine that drives all of the planet's weather, rising bubbles of hot air governed by Charles' law.